Hello, everyone. This webinar is coming to you from Big Shine Energy. We are a full turnkey sustainability solutions provider for commercial, government, institutional, and industrial building operators throughout the US, including Puerto Rico and also including Canada, our neighbor, and Dominican Republic. Today's presentation is the impact of lighting on workplace productivity and employee well-being. Let's take a look at our agenda and our learning objectives. So first of all, when we talk about productivity, automatically we're talking about people. And then the question is, how are people affected by light? And also, how can we use light to optimize the workplace environment so that we optimize not only productivity, but also the health and well-being of our workforce? Also, how do we measure the characteristics of light? We also want to address the question, how do older workers differ from younger with respect to light? We'll talk about something called SAD, or seasonal affective disorder. Who is affected by it, and how can we prevent it? And then finally, we want to know what are the dials that we can turn on our lighting and workspace design to optimize our spaces for productivity. So to do this, we'll learn about what are healthy light levels being guided by IES standards, and we'll learn about something called the circadian stimulus. We'll understand about color temperature, foot candles, lux, color rendering index, and CRI. But we're just going to touch on those briefly to have a basic understanding. This is not a highly technical presentation today. We'll also talk a little bit about the effect of colors on psychology and differences in lighting levels needed between young versus the aging workforce. We'll learn about the effects of seasonal affective disorder, its prevalence, but most importantly, its prevention, because it's actually easy to prevent. And then we can talk about using daylight harvesting, dimming, color temperature, and color changing to maximize comfort, focus, productivity, and wellness. So we all work in different workspaces. We may work in a modern office like this with all the amenities very well lit, or this may be our office. We may work in an industrial setting, in a hospital, in a warehouse. All of these are important for their functions and for the people who are working in them. We may be in a university or college, or we may have a beautiful lounge like this to work and hold meetings in, or to relax. Whatever our workspace is, light is a fundamental aspect of that, and color also is. And so we want to talk about how these can be optimized, and often optimized fairly simply to improve productivity and wellness. Now, we know that LED lighting saves a tremendous amount of money, and often LED lighting and modern controls go hand in hand. This is some actual data from a Big Shine Energy lighting retrofit at a Midwest United States manufacturing facility. And you can see that the blue histogram was the baseline energy consumption per month. As soon as the LED lighting and controls were installed, look at the orange histogram. The reduction in kilowatt hour consumption was tremendous. But what's more important, or let's say equally important to the energy savings, is the potential to optimize our workspace. So let's take a look at how that can be done. So what about productivity? This is actually an older study that was done by the US Department of Energy and by the Rocky Mountain Institute. And they found that when you take and apply energy efficient building and office design practices, you also often get a side effect, which is quite important, which is a side benefit, the tremendous and measurable increase in worker productivity. So these measures are fundamentally improved lighting and also improved heating and cooling. But they found that there was a link between energy efficient design and productivity that could also provide a powerful incentive for efficient design practices. So they focused on cases where these three measures were used together, and they found that there was increased worker productivity, decreased absenteeism, and also even the quality of the work performed improved. In some cases, the productivity gains from energy efficient design, of which lighting was in particular an important part, ranged from 6 to 16%. These are really significant and very powerful benefits. They cited some of the specifics for a number of case studies. Now, again, these are older, these go back some years, but they're still valid today. I'd like to highlight, for example, the aerospace companies. For example, Lockheed built an engineering development and design facility, and it saved $300,000 to $400,000 a year on energy bills. But they also found that productivity rose by 15%. And then the NMB Bank was cited as another example in this study. They moved to a new headquarters building, and this building had been designed to use 1/10 the energy per square foot of their previous building. And yet it cost no more than standard construction. The building was designed for daylighting, passive heating and cooling, and they found that they reduced absenteeism by 15% compared to the old headquarters building. These are really tremendous benefits. Now, I also want to talk about sleep, because sleep is a real problem. That is to say, the absence or the inadequate sleep of much of our workforce today. This sleepiness is found to affect vigilance, reaction times, learning abilities, alertness, mood, hand-eye coordination, and the accuracy of short-term memory. I think we can all agree that these are capabilities that we don't want to compromise on, especially in critical jobs, of which so many jobs are critical. Excessive daytime sleepiness has been identified as the cause of a growing number of on-the-job accidents, automobile crashes, and multimodal transportation tragedies. So who gets a poor night's sleep? A poll that was done by this organization, sleephealth.org, estimated that 7% of the US workforce, that's a very large number of people, and often people in critical roles, that are not getting a good night's sleep. And this is costing up to $45 billion a year in lost productivity. So it's really important that we think about light. We also think about how it can influence quality sleep and how critical that is to our workforce effectiveness, but also to their health. So long-term, the health of our workforce is essential. So how do we describe and measure light? Well, this can get very technical, and we're not going to look at light in this way today. You just wanted to show you that we have this capability. But we want to talk about the basics so that the language of lighting is easy to understand. First, we have to define the level of light. How bright is it? And if we take a candle, a standard candle has a light output of 1 lumen. If we draw a 1 foot by 1 foot square on the wall and move that candle to within 1 foot of that square, the amount of light falling on that 1 square foot is defined as 1 foot candle. If we want to use international units, then we would draw a 1 meter by 1 meter box on the wall and move our candle away to 1 meter distant, and then that is 1 lux. So 1 foot candle is related to lux by the formula you see at the bottom. It's just about a ratio of 11 to 1. Almost 11 lux equals just over a 1 foot candle. Another very important measure or metric for lighting is what's called the CCT, or correlated color temperature. And we can easily relate this to what we find in nature, in the world around us. If we go out on a bright, clear day and we look up into the blue sky, the amount of light that's coming into our eye is tremendous, and it's very bright blue, deep blue color. That's a CCT of about 10,000. But if it's a cloudy sky, then the CCT is reduced to about 6,500, because some of that blue light won't make it down to us. And then just close to midday sun is about 5,500 CCT. You can see it's getting a little more yellow. And so 5,000 K is a very common CCT for LED lighting. And we'll explain why that's a very good place to start. If you look at moonlight, that's a little more yellow yet, and that's 4000 K. The old incandescent light bulbs were very nice at night. Those are 3000 K. And finally, we can look at a candle flame, and that has a CCT that's very red. It's about 18, the CCT is 1800. Now, I do want to point out that the General Services Administration, they're one of the largest landlords in the world. They manage all of the federal buildings, and they have defined in their design document that the baseline CCT for lighting should be less than 4100 K. So they actually discourage or don't allow as a baseline the 5000 K fixtures. However, they do open up the option as what they call tier 2 lighting for color tunable fixtures that can be between the range of 3000 and 6000 K. So that's just something that if we're dealing with a federal facility, we want to keep those requirements in mind. Next, we want to talk about spectral power distribution. And this is something you don't normally have to worry about. This is something for us to worry about and to be concerned with and to measure. But it's important to understand the concept because later we'll talk about spectral power distribution as being one component of what goes into a circadian stimulus number that was developed by the RPI Lighting Research Center. So if we take the light from different lighting sources, and this is a classic LED chip spectrum here, and we break it down into its components, in other words, the wavelength of the light, we can see that it has a peak at about 450 nanometers, the blue peak. And that's because the underlying chip for most LED lighting today is a blue LED chip. It emits blue light. And then what has been applied on top of the LED chip is a phosphor coating that reconverts some of the light transmitting through the coating into other wavelengths. And so then you see the green, yellow, and red. But those properties and the construction can be tailored so that you can get many different types of distributions. So it's just to be aware that LED lighting, even for the same CCT, can have a different spectral power distribution. And that may affect color rendering and also the circadian stimulus. Now, when we're talking about color temperature, it's easy to get confused because we keep saying color, but we want to talk also about office color psychology. And I use some information that I got from the WB Wood website. WB Wood is a provider of high quality office furniture. And they have a very nice webpage called Office Color Psychology. And I would encourage you to go to that webpage and check this out. These are the headings that they start with. So they're defining office color psychology as this collection: emotional responses to color, factors that affect color preferences, how colors impact psychological responses, how colors can influence behaviors, how colors can boost well-being, and also finally, how colors can be used to improve design and safety in work and home settings. So this is a very important subject, and it goes together with the study of the fundamentals of lighting. So here's just one example from the WB Wood website, and I made a little graphic to go along with that. They talk about green being used in the office setting. Green is a soothing color, often linked with the balance of the mind, body, and emotions. Like blue, green is a color associated with creativity and productivity, making it an excellent choice for office spaces. So it's very important that we think holistically about not only light, but also the colors. And if we use them appropriately, we can really optimize our workspace. And there's many studies that tell us about that. For example, I have a paper here called The Effect of Mood Lighting on Human Emotions and Behavior by Dr. Roel Suresh Hanro. And this was published late last year. And it just emphasizes the importance of how we could use not only light, the intensity, but the color of the light, the color temperature, and also the colors in the environment to optimize mood. And these have a tremendous impact on productivity and wellness. When we're talking about color, oftentimes we may want to be concerned about how well are colors being rendered. And that may be very important in a medical setting, so that during physical exam, you can accurately see the color of the skin or whether somebody is cyanotic. But you may also be concerned about the color rendering, the color fidelity of how your products look, or to focus attention, whatever it may be. So color rendering index is one measure of how well the light reflects or renders the colors in an object. The benefit of using this CRI metric, color rendering index, is it's simple. It's a single number from 0 to 100. And generally, the higher the number, the better. We would like to see a CRI of at least 80 for most indoor lighting applications. But there may be applications where it's critical and we want to see 90 or 95 and above even. If color rendering is really critical, there is an IES metric called the TM30. And that's something that if you have an advanced application that requires very critical color rendering, then that's worth looking into. Now, when we talk about lighting, it's always essential that we talk about glare. I think everybody is familiar with the concept of glare because whenever we drive a car at night, the headlights of the oncoming traffic can blind us. It can be very difficult. We have to turn our eyes away, and it's actually somewhat dangerous. So glare is a very real problem affecting us, and it can affect us throughout the day in our workplace. There's actually two types of glare. By the way, when I mentioned headlights, one thing we don't have yet in this country, but we should, is adaptive beam headlights, which are able to adapt the beam to not give glare to oncoming traffic. This is something they have in Europe, but we don't have it here yet. And I am very impatient that we get it. So glare can be direct glare, like the headlight example, and it can be reflected. Anything from reflection off of windows, reflection off of pools of water. There's many different surfaces that are glossy and reflective. And then we can describe how bad the glare is using terms such as it's distracting, it's discomfort glare or uncomfortable, it can be disabling, and finally, it can be blinding. This chart on the right is the effect of glare on contrast sensitivity, which is a key measure of our vision, our effectiveness. And you can see a big difference between photopic vision without glare and then the dotted line showing us how much our vision is degraded when there is glare. So without getting too technical, let's just say that glare is a very big problem. And we'll show you an example of a workplace with high glare. This is a photograph I got from Car Magazine in the UK. And it's a automotive assembly plant in the UK, very brightly lit with LED lighting. You can see it's brilliantly lit, almost overlit. But you can also detect right away that if you look toward the lighting, there's very high glare. If we take a look at our friend here in the right-hand side of the slide, you can see he's looking toward us, but the whole right side of his face is brightly illuminated by the direct light from those fixtures. If he turns his face back toward the right, he will have to look down. He won't be able to look toward those lights for very long because of the tremendous glare. Now, glare control can be all different ways. It can be with, of course, the positioning of fixtures, but very often in office settings, we just have to work with the grid that we're given, especially in retrofit situations as opposed to new construction. And even then, if spaces are repurposed, fixtures are not often exactly or perfectly located for where you want, depending on where we're going to be working beneath those lights. So glare control may be as simple as putting on a visor or putting up a little shade or a banner of some kind. There's all kinds of ways to deal with glare. And it's worth taking a little effort to help every employee be working in a glare-free setting. And task lighting is very helpful because you can position that task lighting behind you or next to you to make sure that your work area is well lit without having glare in your affecting your vision. Something else that is talked about in the context of lighting is a phenomenon called flicker. This was first noticed to be a problem when fluorescent lighting was first introduced. And the ballasts at the time, the ballast being a electrical device that's used to regulate the power going into the fluorescent tube to help it to start properly and then to maintain a stable arc inside that mercury vapor in the fluorescent tube. They found that with the magnetically ballasted fluorescents and other types of like high pressure sodium lights, there was a flicker that you couldn't necessarily detect readily with your eye, but workers and students in classroom environments, many different environments with these lights, were complaining of eye strain, headaches. So it was having a physiological effect, even though we couldn't necessarily see it. Then at the other end of the spectrum, or in terms of effects, if we're doing video conferencing or high-speed video photography, then flicker is very important so that we don't affect the quality of our recording. So the discussion of flicker is kind of technical. There are many good references on that, and we can show you ART standards, which are those the flicker-free and flicker-free special limits. Those are the big shine limits that we set for ourselves. But we're very glad to go into the discussion of flicker if you have an application that's critical for that. But if it's less than 10%, which is what UL defines as low optical flicker, and if depending on the frequency of the flicker, you're not likely to have any problems, as the IEEE chart on the right will display. When we're talking about lighting, it's very helpful to talk about beam angle, because this is a characteristic of the individual fixture. And when you go to place fixtures in the workspace, you're going to be concerned with the beam angle so that the light distribution and the light direction is optimized. And some fixtures have the ability to change either the beam angle or to change the orientation of the beam. But simply defined, if you take a fixture like this little notional high bay you see in the center, and you look at the light distribution underneath it, the peak lighting intensity will be at point A, directly under the fixture in most fixtures. Not all, some have optics built in that change that. But this is to illustrate the concept. If you travel outside of that point, go away from the center, you'll come to a point B where the illuminance, the intensity of the light is 50% of what it was at point A. If you then draw a circle or a shape of all the point B's all the way around until you come back to where you started, that will define the beam angle distribution. Now, there is something called field angle, which isn't usually talked about much. That's the point where the illuminance is only 10% of what it was at the center beam. And that's typically the point outside of the field angle where there's effectively no light, no usable light from that fixture. But we take all this into account when we do lighting for you. You don't have to worry about this. This is just to make you comfortable and familiar with the terminology of lighting. We'll take care of all the details and we'll show you how the lighting will work through photometric designs. Now, this is a good time to talk about our population, our workforce, and the aging population in particular, because there are still a lot of people who are working. For example, I'm in my 70s and I'm still working full time. So what are my requirements for light as compared to a younger and middle-aged workforce? So the first question is, the older population is more sensitive to glare. Is that true or false? I'll give you a moment to think about that. The answer is true. The older population is more sensitive to glare. So a younger employee in a given location or a given setting might not complain about glare, but an older worker may. It may be bothersome to them. And they're not making it up. It's just the physiological changes to the eye over time affect how our vision, and we become more sensitive to glare. Second question, the International or the Illuminating Engineering Society, IES, has recommended illuminance targets in lux, and they have the same tables and foot candles. And they have age-related categories. And I'm just going to go right to the answer. What are the categories that the IES has defined for illuminance targets? In other words, how bright should it be depending on the age of the people in that workspace? Here, the correct answer is B. So they define categories for if at least half of the people in that space are under 25 years old, or if at least half are in the range of 25 to 65, or finally, if at least half are over 65. So those are the three categories that IES has determined they need different levels of light. Now, then the question is, how much more? So the oldest category, age category, this is question 3 now. So you can circle B, that's the answer to question 2. Question 3, the oldest age category, meaning at least half are over 65 years old, is recommended to have at least blank times as much light as the youngest. The answer is 4 times. So if you're recommended to have 1 unit of light for the under 25 workers or population, they may be students, whatever the category is, you need it. It's recommended to have 4 times as much light if at least half of the people in that space are over 65. So this can be quite a challenge to regulate lighting to deal with, especially if the demographics of the people in the space are going to change. And so I'll get into a simple way to mitigate that concern. Finally, a question is, we have to always think about how much time we spend looking into our digital devices, our cell phones, and especially our computer monitors. So the question number 4 is, computer monitors can be up to blank K. This is referring to the CCT, the color temperature. You remember the range from the very red at 1800 to midday sun at 5000 or 5500. Well, the answer is computer monitors can be up to 6500 K. This is a lot of blue light. That's not bad early in the day, but as the day goes on, I recommend that you consider using the night light setting on your monitor, and you start making your monitor more go further and further into the night light setting. So for example, on my monitor, if I set it to 50% night light, that 6500 K, which has a lot of blue light, which is very good early in the day. But later in the day, if I've been looking at my monitor all day, my eyes are very irritated. And also it can affect our sleep. And I'll discuss how that's possible. 50% nightlight setting reduces the CCT to 3900 K, and 70% it's down to 3100 K. So you can see you have a lot of control over that. It does, of course, look a little bit brown. And I recommend as a tip that when you turn on your nightlight, go past the setting that looks comfortable to you and then bring it back a little bit. Your eye will get used to, for a moment, looking at the very brown screen with a high nightlight setting, and then bring it back to 50 or 60%, whatever's comfortable, and it'll significantly reduce the amount of blue light. It'll lower the CCT, but it will look comfortable and to view. Now let's talk about seasonal affective disorder. This is a very serious disorder, and it's important. We're starting to come out of the peak time of year where seasonal affective disorder is a problem, but it is something that will recur every year, and it affects about 6% of the US population. It also lasts about 40% of the year. So we're talking about a lot of productive time here that's affected. What is SAD? SAD is a biochemical imbalance in the brain prompted by shorter daylight hours and less sunlight in the winter. And then The most common age when this first manifests is between 18 and 30 years old. And also, SAD occurs much more often in women than it does in men. Now, I have a personal connection to this seasonal affective disorder. Let me explain. There was a very well-known physician in suburban New Jersey, and he had a patient. The patient was a scientist named Herb Kern. Herb worked at the Bell Labs laboratory, and he came in one day and he said, Dr. Cruzy, I've noticed that every fall I start to become depressed. I don't feel like working. I don't want to get out of bed. He explained all of these symptoms, which we now would say these are classic symptoms of seasonal affective disorder. But this was something novel at that time to be breaking down the symptoms in such a methodical way. And then Herb said that he had been watching these symptoms and categorizing them, doing all the statistics for several years. And he said, I'm sure this is a very important problem, and I don't think I'm the only one who has it. Do you think anybody would be interested in my statistics? Well, the doctor was like instantly said, yes, absolutely. In fact, Herb, do you mind if I take these to the NIH and show this to them? And Herb said, sure, if anybody can benefit from what I've experienced, please, I'd like to help people because this is a terrible thing. I really feel crummy in the winter. And so Dr. Cruzy took the information to the NIH, and at first they weren't interested, but he was very insistent. And so finally they said, okay, we'll take a look at it. And then sure enough, they said, this is important. And they were the ones who coined this term, seasonal affective disorder. But we really have to give thanks to Herb Kern because he was the one who prepared all of the information, did all of the statistics and data collection and analysis to prove that this was really affecting him tremendously. By the way, Dr. Cruzy would have been 100 years old this year. And I think this was one of the big achievements, one of the big moments in his medical career. And he would have been very happy, I think, that we are talking about this today. So what are some of these symptoms? Increased sleep and daytime drowsiness, social withdrawal and increased sensitivity to rejection, irritability and anxiety. It can include feelings of guilt and hopelessness, fatigue and low energy level. That's very common with SAD. Decreased ability to focus or concentrate, trouble thinking clearly. This is a big one too. Increased appetite, especially for sweets and carbohydrates, and the result of that, weight gain. So this is a heavy burden for all of us to bear if we're affected by SAD. Not everybody is, but for those of us who are, it's significant, and we want to combat that. So what can we do? Well, the answer is something called the circadian stimulus. And I'll be talking about research at the RPI Lighting Research Center, RPI meaning Rensselaer Polytechnic Institute. So they say that light is the master signal for our internal clock. Every one of us has a biological clock inside, and our hormones, all of our bodily functions are strongly regulated by that internal clock unless we dysregulate it. And then many bad things happen. And I'll talk a little bit about that. So early morning light, especially high CCT light, remember that's a light with a lot of blue in it, suppresses melatonin production. So we don't feel sleepy. Now, optimizing light means optimizing the circadian stimulus with the time of day. And RPI has pointed out that it's light through the eye, which is the most effective input that regulates or sets our circadian or biological clock. And that will entrain us to the 24-hour solar day. So this is what RPI has come up with. They developed something called the circadian stimulus. This was a metric developed at RPI. And I want to give credit to Daniel Frering and the research staff at this Lighting Research Center. The exposure to a CS or circadian stimulus of 0.3 or greater at the eye for at least 1 hour in the early part of the day is effective for stimulating the circadian system. So we want to think about this as something that it's very important that we get the right kind of light at the right time of day, and it will sort of get our clock going, connected and synchronized throughout the whole day. Now, we can do things that will disrupt that later, but if we have a little bit of understanding about the circadian system, then we'll know how to prevent that from happening. A circadian stimulus of zero point 0.3 has been shown to improve sleep, mood, and behavior. So again, for productivity and for wellness of our workforce, or to help patients in the hospital or whatever the setting may be, our students, they all need this to be appropriate. So the lighting needs to be appropriate for the time of day. So the same circadian stimulus level can be obtained with various combinations of light levels, meaning the intensity in foot candles or lux, the spectra, and the duration and light distribution. So there isn't like a single fixed way to get a given circadian stimulus. There's many different ways, but the timing of the bright light and the CCT exposure matters. Light on the retina is the master signal to set our circadian rhythm correctly. And the big payoff for doing so is optimum health. Here's just one journal article that will tell you about how important it is to get this circadian stimulus as part of our daily routine. So this was a journal article from 2023, Brainwashing and Neural Health, the role of age, sleep, and the cerebral spinal fluid melatonin rhythm. And they said in the abstract, melatonin is a sleep promoting agent, with waste clearance from the central nervous system being the highest, especially during slow wave sleep. Melatonin is also a potent and versatile antioxidant that prevents neural accumulation of oxidatively damaged molecules, which contribute to neurological decline. So I think we can all agree that we do not want to develop dementia or Alzheimer's. And so it turns out that our sleep, getting a good sleep, is really critical, because this is the time when our brain is being cleaned up. And this system, the cerebral spinal fluid melatonin system, is essential to be set correctly so that we can clean out the metabolic byproducts in the brain and refresh our brain. Also, this other article in Nature and Science of Sleep, short and long-term health consequences of sleep disruption. They said that short-term consequences can include heightened stress response, pain, depression, anxiety, also cognition, memory, and performance deficits. That's again a heavy burden to put on our workforce if they're not sleeping well. In adolescents and children, disrupted sleep can lead to poor school performance and behavioral problems. And then they go on to say that long-term consequences for otherwise healthy individuals include hypertension, dyslipidemia, cardiovascular disease, weight gain, metabolic syndrome, and type 2 diabetes mellitus. There's also evidence that sleep disruption may increase the risk of certain cancers. So, is it important to get a good sleep? Yeah, you bet. It's very important. Also, for mood, especially with respect to depression, many people are suffering from depression, and depression is a drag and really affects our lives. But it's found that high circadian stimulus lighting is a therapy for depression. Let's see what this Frontiers in Neuroscience article said. Bright light therapy has been proven to be an effective and comparatively safe form of depression therapy. It is widely used in clinical practice and is included in therapeutic guidelines for both seasonal affective disorder, but also, and I want to underline this, for non-seasonal depression. Also, they go on to say that the circadian stimulus model, which is what we talked about, the RPI metric, was used to quantify the efficacy of lighting in bright light therapy. So we can see how important the circadian stimulus is. And again, this gets into a technical derivation, but we can help you with that. That's what our role is, to help you. So all you need to do is tell us that you want to be able to analyze the circadian stimulus in different workspaces as part of our lighting installation, and we'll do that for you. So high circadian stimulus lighting showed a significant reduction in depressive symptoms, and the better therapeutic effect was seen when it was above 0.57. So that's a very bright, well-lit workspace. And then finally, they say that there's different types of light that can be used to obtain a significant treatment effect. But also they mentioned that older adults are not as responsive. The reason being that changes to the retina, cornea, and lens increase the absorption of short wavelength light, which is your blue light. So what's the conclusion? The circadian stimulus strategy may need to be tailored for an older workforce. And then finally, good news for those at risk of Alzheimer's disease, and we all are actually over time, that lighting with a circadian stimulus of 0.3 is still beneficial as depression therapy. So we have many great options for office lighting. I'm just going to show you a couple of examples. I'm going to sort of highlight three today, but we have dozens of different lighting fixtures for all different kinds of workspaces. So the big shine LED panels with Lutron dimming. And these are something dimming can be used very effectively. So even if the LED panels have a fixed, say 5000 K color temperature, dimming can be used very effectively to vary the circadian stimulus so that it's very high in the morning and throughout the day. And then you can taper it down after 4 or 5 p.m. and go very low if you have to work late till 10 or 11 at night, whatever it might be. But we also have a wireless LED panel, which is color changeable. It can be changed in 4 different steps from 5000 K to 4000, 3500, and finally 3000. And it is also dimmable. So you have 2 options with that panel and it can be done so that you can personalize your light requirements. And then finally, if there's a special requirement, we have color changing downlights, which can mimic sunlight. So I tried to capture with the photographs what this looks like. So 5000 K. In the, excuse me, in the upper left, that's very blue rich, but very bright, brilliant white light. That's a very bright white light light workspace. 4000 K is also very popular for our office lighting, daytime lighting. And it just, the color rendering is a little different, as you can see here. Also, if we then use this color changeable panel and reduce it to 3000 K, you can see how it's getting more and more yellow and becoming warmer. Even if you look at the black and white photograph, you can see that the rendering goes from sort of more starkly white and black to more brownish. And then finally, if you need it, the special light that mimics sunlight, it has 3 settings, and the warmest color temperature is 1800 K, which is like candlelight or campfire. And so you can see the difference there. So you have 2 different possibilities. You can use LED panels at a fixed, say 4 or 5000 K with the dimming. You can use the color changeable and dimmable, and you can add for special requirements, the sunlight mimicking. So putting it all together, light is a powerful tool for health and productivity. Bright 4000 or 5000 K LED lighting is energizing, making us feel alert and focused. And you also saw that it directly prevents or helps to overcome depression, both seasonal and non-seasonal depression. Now, we may need to add glare control to optimize specific workspaces. And as I mentioned, that can be as simple as a visor that you put on or a little barrier or banner of some kind to block glare light. You just have to be able to notice that it's coming, and then this is a disturbing factor for your employees. And the best time for the high circadian stimulus lighting is from 7 a.m. to about 4 p.m. And don't forget the role of our computer monitors and cell phones. They have nightlight settings, and they should be used every day. So ideally, we want to step down the lighting level using dimming as we get into the evening. But we can also use color changing. So if there's a need to have very bright light, but we don't want to disrupt the circadian uh, process or setting, we can use color changing, and going to a warmer color temperature without changing the brightness can help us. And also task lighting can be used. So if you want to dim the entire space, but certain workers say it's too dim for me, task lighting is a great way to personalize the space without a lot of effort. Also, as you saw, judicious use of color can further enhance a room. Older members of our workforce may need higher levels of light, but they'll also be more sensitive to glare, and they may be more responsive to high levels of warm, meaning lower CCT light. So light is a proven antidote for depression. This is our conference room in our Newburgh, New York headquarters. And you can see we've got the Big Shine LED 2x2 panels. We have LED accent lights, and we're using the Lutron Vive dimming controls. Now, this CS, the circadian stimulus, as you see it now, is about 0.45 with all the fixtures on at 100% output. So this is great. This is very bright, energizing. Nobody is depressed when they're working in this workspace. But later in the afternoon or into the evening, if we need to, or also to highlight what's going on, say at the front of the conference room, we can dim selectively. We set it up to dim in two zones. The forward three fixtures dim separately from the rest of the lights in the room and the accent lights. And one thing we like about the Lutron system, you can see there's a little toggle switch here. And if you hold it down for a couple of seconds, it will step down in increments. That's what those little dots are on the left side of each dimmer button. And the benefit of that is once you calibrate it for a certain circadian stimulus, it's very easy to go right back to that exact setting. You don't have to take a slide bar and kind of slide it up and down and guess about where it should be. So how can we help you with your lighting? Well, actually, we can help not only your lighting, but all different aspects of energy conservation and workplace improvement. We do ASHRAE level 1, level 2, and level 3 energy audits. We'll do photometric designs of your space, not only to meet codes, but also to meet your special needs. And then we have a whole array of state-of-the-art LED fixtures with very high efficacy, meaning they save a lot of energy, fixtures of every type needed for commercial, industrial, institutional, and sports lighting. We also have all types of control options for energy savings, daylight harvesting, and also for circadian stimulus tuning. Some of the fixtures that we have power level selection for high-end trim, meaning we can preset it according to what's needed for the space. And then some have color temperature selection, so that again, you can fine tune individual requirements, even if you're buying all the same fixture for a given, say, warehouse location, but there's a warehouse desk or space in one part of the warehouse. And then finally, we have fixtures for many special requirements, which might include high operating temperature or even explosion proof. We offer Lutron and other controls, and also Niagara-based building management systems. We do solar energy PV systems and battery energy storage systems. We do EV charging stations, and we install smart meters, power quality meters, and we can provide AI software for demand forecasting and also reduction. So I just wanted to show a few graphics to illustrate the process of doing photometric designs. This is sort of a high level, like a drone shot of a facility where we're looking at the area light distribution around the facility. But we can also do any kind of office space, from something very basic and simple like this to, here's not an office, but here's a brewery. And you can see we did a 3D model of the brewery and then did the photometric analysis, taking into account the locations of all of the special aspects of the brewery. So whatever it is, whether it's a simple array of desks in a workspace or something that looks like this, or an auto dealership, we can do photometric design and 3D rendering to show you ahead of time what your upgrade will look like. I mentioned we also do sports lighting and sports lighting of all different types. This is an example, the Yogi Berra Stadium at Montclair State University, and it was lit with these high mast lights were metal halide. And by replacing them with our LED lights, they're going to be saving about 150,000 kilowatt hours per year. But on top of that, the lighting is better. It improves so much that they are now eligible to have their sports events broadcast on ESPN, whereas before they could not. So they get better lighting and energy savings at the same time, which is a tremendous benefit. So whatever your workspace requirements are, every place we work, we need lighting. We can provide that. I wanted to just mention briefly, I said that we perform energy audits, and that of course includes lighting audits. So fundamental to every workspace, the LED lighting upgrade and controls is what we would call the low-hanging fruit of not only energy improvement, but also workplace improvement. And we also recommend that whether you're doing audits or ACM energy conservation measure upgrades, this is a skill set that's recommended. The Association of Energy Engineers has several certifications: CEA, Certified Energy Auditor, the CEM, Certified Energy Manager, and also Certified Building Commissioning Professional. ASHRAE has a certification called BEAP, Building Energy Assessment Professional. Niagara certification, which is a certification for if building automation or building management system is in the plant. NABCEP has several certifications for both designers and installers of solar PV systems. And then there isn't a sort of a universal certification for battery energy storage, but there is one example is STEM University. STEM provides battery energy storage systems with AI controls. And then there's lighting certifications of different types, and also CESCO, and Certified Environmental and Safety Compliance Officer. And then finally, last but definitely not least, I didn't want you to think I skipped over IS Networld. That I wanted to actually highlight it, because if you have contractors coming in to work on your space, or a solutions provider, for example, like Big Shine, you want us to be IS Networld certified for safety, so that you can be comfortable that we're following all of the correct and best practices for safety. And I want to mention that we at Big Shine, we have at least one of every one of these certifications. And for several of those, we have multiple team members who are certified with these certifications. So to put it all together, energy savings is a place where we start, but you have the opportunity to greatly optimize your workplace. And with lighting and maybe some judicious use of color and lighting controls, you could make a tremendous difference, and your workforce will realize it. They'll see the difference the moment they come in and every day, and they'll realize that you did this because you value them and you want to provide the best environment for them. And then we do all these other things, not only saving people energy through lighting and controls, but through all of these other measures that you see in the upper left. So we have fun when we do our work. Sometimes we get into unique challenges, like having to bring in HVAC equipment with helicopter. And then we do, as I mentioned, BMS. We're fully capable there. And then solar energy, solar PV. This is a fantastic technology, and battery energy storage systems. And as you can see, we love our work. We do this because we have a passion for sustainability and a passion for helping you to have an excellent and highly productive and delightful work environment for your employees. And then finally, we do EV charging stations. So I want to thank you very much today that you allowed us to come in and share this presentation with you. If you have questions, please reach out to us by phone or by email. And Yogi Berra thanks us for the lighting of his stadium, but also we get spontaneous thanks from the workers at all the different places where we go. When we've done lighting upgrades, this is one where I just, a spontaneous thanks from the employees of a workspace that we went in and did lighting in the work in the shop. And they said, "This is great. Thanks for the lighting." So it's been my pleasure to be with you today. And please reach out to us if we can help you with your workplace and with energy conservation and sustainability. Thank you very, very much.